Hi there, math friends, and welcome to section 1.3, where we're now going to take the transformations that we've been learning, all 10 of them, and we're going to learn how do we actually translate on a graph visually. So what we have is we have an f of x graph over here, and the first question says, well, let's just start simple. Can we graph f of x plus 3? The first important thing to figure out is these two questions. First of all, what's the transformation happening in f of x plus 3, specifically the plus 3? And if you remember from all the different transformations that we learned, plus 3 means that we are traveling on a vertical direction, and in fact it is up. And when it is a vertical change like that, we like what's happening. It looks like a plus 3, so it is definitely going up 3. So we're going to take this graph on the right-hand side and shift it up 3. The best way to approach this is to find what we call sort of the bullet points or the important points or skeleton points. And we don't want to graph every single point that's on here one at a time. It'll take forever. Oh my gosh, ain't got time for that. But if we can find these important points, it'll make it a little bit faster. Now, by important points, what I mean is the endpoints are great ones to choose. And then any place where the graph changes direction or you see little corners here. So I outlined in yellow 4 really good important points. I'm going to put those on an XY chart. And when I transform those, I'm going to transform and make a new graph. So those yellow dots, how about going left to right? The farthest left one is -3, -2. The next one is over at 0, 3. The next one over is 3 and then down 1, so -1. And the last one is 5, 1. Like I said, we could put more points on there if we want to and transform them, but it would just take a long time. So I think these points are good choices. Now, as we see here, because we're moving up 3, we're going to change all of the y values because up and down is a vertical change. And like we said, we like what we see when it's an outside or a vertical change. It's plus 3, so we are going to be adding 3. So that means we don't touch the x's at all. Leave the x's alone and just change all the y's by adding 3. All right, let's do it. So on our new graph, especially on the new chart here, the x's stay the same. And now I'm going to take all of my y values. I'm just going to plus 3. So -2 plus 3 becomes +1. 3 plus 3 becomes 6. -1 plus 3 is 2. And 1 plus 3 is 4. What I'll do is I'll take these brand new x, y values and I'll graph them on the grid on the right. Let's see how it looks. All right, -3, 1 is right about here. 0, 6 is up here. 3, 2 is here. And 5, 4 is up here. There we go. And why don't we connect these just going left to right? So going left to right, this goes up to here, this goes to here, and this goes to here. And we should be done. Does it look like it went up 3? Let's go back to the original. It was there. It looks like the bottom was at -2. So if it shifted, it should be up until 1 here. Yeah, that looks good. We did it. We're done. And that's basically how these go. So we're going to make little XY charts of the points that are important, like we said, starting and ending points, and then any changing, increasing, decreasing points, little corners. And we're going to transform them according to what we see in the given problem. Ready? Let's try number 2. Number 2 says, let's graph f of x minus 2. So remember, if you see a change on the inside, that means that's an x change. So something horizontal is happening, and it's -2. Remember, anytime we see an x change, we always have to do the opposite of what we see. The -2 makes me think, oh, it's minus. That means it's going to the left, not to the right. But no, since we're thinking opposite, x minus 2 means we're actually going to the right too. And that's kind of tricky. You'll get used to it the more you practice these. But this is an x change because it's on the inside, and it looks like it's going to the left, but we're actually going to the right too, which means we're changing the x points, which means we don't have to change the y values. Now I'm going to take the same original points that we had on the previous page. So let me go there for a sec. And our previous points were over here. So I'm just going to copy those and bring them over. That was -3, -2. That was 0, 3. Oops. And 3, -1. And 5, +1. Okay. Now if I want to do x minus 2. That means I'm going to take all the x's and I'm going to move it to the right. Now, if you think on a number line over here, when you move to the right, I know it looks like you're subtracting 2, but you're actually going to be adding 2. This whole idea of the opposite. So when you go to the right on the number line, you're going to be adding to all the x values, which means the y's will stay the same, but the x's will change by adding 2. So how about negative 3 plus 2, 0 plus 2, 3 plus 2, and 5 plus 2. Let's see how that looks. I'll graph them over here on the right side. So we get negative 1, negative 2. We get 2 comma 3, 5 comma negative 1, and 7 comma 1. Okay, shall we connect them? Here we go. Doot, doot, and doot. Again, if I tried to compare it with the OG up here, where I am now, it does look like that it moved over 2. That means we got it. Good job. So again, we're going to pick these original points and some easy points to pick. And then depending on what the transformation tells us, that's the x or y value. And if it is an x change, remember any x changes, we always do the opposite. Okay, try another one. Now before I even start, I'm just going to copy down the OG points right away. Okay, ready? Can you figure this one out? There's a 2 multiplying in the front. You want to take a minute and think about what that is? All right, it is on the outside, which means it's a vertical change, not a horizontal, which means it's happening to y. And remember, things that happen on the outside with y's, we like. It does exactly what it looks like. This one looks like I'm multiplying by 2, right? And we call that a vertical stretch. So what it's going to do is it's going to pick up our function and it's going to stretch it up and stretch it down. Now, like we said, you're going to take all the y values and multiply by 2. So x's stay the same. But now the y values are times 2. So how about times 2, times 2, times 2, and times 2? Okay? But it really helps that you remember what these transformations are as soon as you see what they are. All right, I've got negative 3, negative 4. I've got 0, comma 6, 3, negative 2, and 5, comma 2. When I connect that left to right, and again, I compare it to the OG. Even if I compare it up here, I know this is not the original. It's the same one, just shifted over. Look at how the size, look at how it's sort of stretched up and stretched down. So it's a little bit higher and a little bit lower. That's a vertical stretch. And what happened? It was a timesing by 2 on the outside. That one's done. All right. Now, as we get more complicated, as we add more steps, really try to figure out what do we do first. Because if we go out of order, we actually might get a different graph than the original one or the correct one. So this one, I see 2 different things. I see some kind of multiplying on the inside. So I know that's probably some kind of stretch or shrink. And then over here, I see a +1 on the outside, which means it's up, down, left, or right. You should always do the stretching, shrinking, the multiplying first before you shift up, down, left, right. Okay, so let's figure out what this 2x thing is. Notice it's on the inside, which means it's affecting x, so it's horizontal. And didn't we say before, remember when we said up here that whenever it's an x change, it's always the opposite? So it looks like I'm multiplying by 2. Looks like I'm taking all the x's and timesing by 2. But no, we do the opposite, right? So we're actually going to be dividing the x's by 2. It looks like a big number, 2x, but it's actually called a horizontal shrink. So when it's with the x on the inside, you do the opposite of what it looks like. We're going to divide the x's by 2, and it's called a horizontal shrink. And then let's deal with the other part. This +1's on the outside, because that's on the outside. That's a y change. And remember, plus or minus, that's an up or down. So this one's actually going to go up 1. Ready? So here's our OG points here on the left. All right, now as you make a change, something that's kind of fun is I just go through each point and I cross it out and I write the new point next to it. So for example, if I just look at the x's, remember we said, let's do the stretching and shrinking first. So we'll do the 2x, which is divide by 2. So I'm going to divide all my x's by 2. I get negative 3 over 2, which is negative 1.5. If I divide 0 by 2, I still get 0. Divide 3 by 2, I get 3 over 2, or 1.5. And divide 5 by 2, and I get 5 over 2, or 2.5. All right, now that one's done. How about we go over here and work with the y's? Now we said the y's is going to go up, which means you're going to add 1. So -2 plus 1, 3 plus 1, -1 plus 1, and 1 plus 1. So ready? Here's our new points. -3 halves, comma, -1. Just reading straight across. If we do it right, this should look like a horizontal shrink. So it's going to squish in from the left and the right, and then go up 1. All right, so we got to be good with our little halves here. It's kind of a small grid. Sorry about that. But I've got -3.5, -1.5, comma, -1. It's right about there. How about 0, 4, 1.5, 3 halves, comma, 0 is about there. And 2.5, comma, 2 is right about there. It's kind of squished together, but that was the point, wasn't it? Didn't we say it was a horizontal shrink? So we took our OG graph and we squished it in left and right, and then we basically just picked it up and moved it up 1 at the end. But again, most importantly, folks, make sure you always do the stretching and shrinking before you do any up, down, left, and right. All right, ready? Here comes another cool type. Remember the negatives. If you see a negative, what does that do to our graph? Okay, you think about that while I put down my original points here. We had -3, -2. We had 0, 3. And you're thinking, what's f of -x? Did you figure it out? Okay, you're thinking. All right. Whenever you're multiplying by a negative, that's what's called a flip or a reflection, x or y axis. And we learned that if it's on the x, it's an actual y axis reflection. If it was on the outside, that was an x axis reflection. So because this is on the inside on the x, that's called a y-axis reflection. But, because it is on the x, you are going to take the x's and multiply all the x's by -1. So we still stay true to what that looks like visually. It's multiplying the x, so we're going to multiply the x. But it makes what's called a y-axis reflection. Okay, so I'm only going to be multiplying the x's, so the y's stay the same. Now, basically just going to change the signs of the x's. So -3 goes to +3. 0 times a negative stays 0. 3 becomes negative, and 5 becomes negative. So it just flips the signs. Now watch what happens. This should now do a y-axis reflection. So over this vertical line, everything should just sort of flip over. Let's see. I get 3, -2, 0, 3, -3, -1, and -5, 1. Okay, we can graph this left to right. And again, if I go all the way back to the OG, there it is. You see how it had that big mountain and then an upside down small mountain? This one has the small mountain and then a big mountain on the right. So it just flipped over this y-axis. That's a y-axis reflection. But how did we do it again? We multiplied the x's by -1 because that's what we see. If it was negative on the outside, that's called an x-axis reflection, but we're still going to be multiplying all the y's by -1. All right, you ready for your final challenge? I think you can do it. Okay, can you figure out this one? All right, in the meantime, I'm going to write in my OG points. -3, -2, 0, 3, 3, -1, and 5, 1. Okay. Now, believe it or not, there are 1, 2, 3, 4 transformations happening in number 6. Okay, I definitely see the -1 on the outside. So I know that's going to go down 1. It's on the outside, it's a y change, and it's exactly what it looks like. So we're going to go down 1. I see the +1 on the inside. So this one's good. I'm going to kind of mentally cross that out. I see the +1 on the inside. That means it's either going to go left or right. It looks like it's right, but it's really going left 1. Okay, so the +1's the left one. Now that -2 is actually 2 different monsters. We're going to deal with it differently. Let's just deal with the 2. The 2 is multiplying the outside. That's a vertical. And we like what it looks like. It's big, so it's called a vertical stretch. The negative, remember, we just did before, the negative is a reflection. And what kind? It's on the outside, so it's an x-axis reflection. So treat the negative and the 2 as 2 different transformations. That's why there's 4. Now, what do all these mean? Let's see. X-axis reflection, if you remember, the negative was on the y, So we're going to multiply all the y's by -1. Vertical stretch, we're going to do exactly what it looks like. So we're going to multiply all the y's by 2. The left one means we're going to take all the x's and move to the left, which means you're going to take the x and you're going to subtract 1 when you go left. Remember how that's the opposite? It says +1. You think the opposite. And then finally, the down one just means you're going to take all the y values and subtract 1 to go down. Now, the order in which I wrote it here is really important. We always want to reflect first, and then stretch and shrink. And the last step is to shift it up, down, left, right. Always go in that order. Otherwise, if you reverse it, you will get a completely different graph. So we're going to do the x-axis reflection first. Here's 1. We'll do the vertical stretch next, and then we'll go left and we'll go down. Now, can we do like number 3 and 4 interchangeably? Yes, you can do that in either order because that's considered like your last step of shifting. So you can go 1, 2, 4, 3, or 1, 2, 3, 4. All right, ready? So let's do the x-axis reflection, which we said was -1 times y. So times -1 times -1 times -1 times -1. Yay, check. Okay, next step. Let's take those y values and we're going to multiply by 2. Ready? Okay, so y values times 2 times 2 times 2 times 2. Yay, check. And then let's move left 1. So we're going to take all of our y values, my x values, and subtract 1 because we're going left. Subtract 1, subtract 1, subtract 1, subtract 1. And last but not least, let's go ahead and subtract 1 from our y's to make it go down 1. That's a y change. So subtract 1, subtract 1. Gotta watch these negatives. There you go. It's kind of neat looking, seeing all the crossings out and seeing what our actual new points are. So this is x comma y, x comma y, x comma y, x comma y. Let me write this in the chart here for you. My final point transformed is -4 comma 3, and then -1, -7, 2 comma 1, 4, -3. Really important that you stay organized, stay methodical. Don't really try any guessing. Just go and make a chart, a couple of points here, and just transform it in the correct order like we saw up here. All right, my new points, -4 comma 3, -1, -7, 2 comma 1, and 4 comma -3. And if I graph those, moving them left to right, and I graph it, and I graph it, there you go. What did we say it was going to be? It was going to be an x-axis reflection. So you see it move over the x-axis. It's flipped upside down. It looks like it's been stretched vertically. And then we picked it up and we moved it a little bit to the left and a little bit down. So as complicated as it looks, folks, it's really not that bad. Take it apart, look at all the transformations, and try to do it in the order that we have. How does that sound? Awesome job today. Have a wonderful rest of your day, math friends.